Alrighty, in this video we are going to continue working on our handing off of games from the master server to the region server. The first thing I want to do is I want to handle that to-do that we had. Actually, I think what I'm going to do here is just search for to-do, and it seems like we have a couple. Bootstrap, don't care. jQuery, don't care. But we have one in game lobby. And this is actually something that I wanted to address. And the reason that I wanted to address this is I believe we have a race condition. See, I was looking at this code just a few minutes ago. When we begin the game, we do game servers begin game, which shoots off that whole madness. And then when it's done, we re-enqueue on our fiber and then invoke on game started. Now, we do set status to starting game right here before we shoot off the request to begin game, and we are in the fiber, so we can ensure everything's synchronous. But on game started requires, or what it does is it matches up the rows that we're creating in the database to the individual players that we have in memory. And the problem with that is that could become out of sync. There's a potential there's a potential race condition here where if a player was added after the game has started, then we will run into an issue of having a mismatch between what's in the database and what we have in memory. Same thing with a player leaving the game before the game started. I don't know how I want to handle that. I think I would want to have that be allowed, having a player abandon a lobby while a game is being started. I think I want to have that allowed and maybe just count that towards the player having abandoned the game. That actually is a good point, something that I might have to give some more thought. But definitely I don't want to add players while the game is being started. So we already have this helper right here, this ensure is active, which throws an exception if we're not active. And what I'm going to do here is I'm just going to take that and I'm going to find our to-do right here. We have this to-do validation. And this is the add player internal method, which we've kind of established that if we have this internal suffix on our methods, that indicates that this method's always going to be invoked on the request fiber, or on the synchronization fiber. So basically, the to-do validation, all I got to do here is basically replace that with ensures active to make sure that if a player tries to join the game, that it'll throw an error. We would also want to do a couple other things. Make sure that they're not disconnected and then add the disconnect handler. But then immediately after that, we want to make sure that they're not already in a game. So I think I'm going to add a check if player systems contains game lobby system, then throw new RPC exception player is already in a lobby. So this ensures that that we don't add the game lobby system twice. So if we think, so that's basically what I'm going to add here. Ensure is active and that. So if we head on over to remove player, that just invokes remove player internal. Remove player internal is not invoked anywhere else. Let's see here. We could add another check here to if the player lobby does not equal null. We could also say or player or not player systems. I'll do this before. If not players context systems contains game lobby system and player or player lobby does not equal this. So add that check in there. So if we think, what would happen if a player was removed while the game is starting? So we know that we're in the right fiber. Let's see here. I think actually the most trivial way to handle this would be if the player is removed, but he's in the database when the game is started. So we loop over all of our players. Yeah, we'll think about that later. I want to add another check, though. Begin game. Begin game, we never ensured that the lobby was active. So right now, as of right now, you could technically try to begin the game twice, which would cause all sorts of madness. So we also want to set ensure is active there as well. But that should about wrap that up, actually. So we start the game and blah, blah, blah. Destroy internal and all that fun stuff. Now that's another interesting race condition. So we begin the game by we set the status, we begin the game, and then what if the lobby is destroyed? So the lobby gets destroyed on game started. It also gets destroyed when we tell it to be destroyed, and or the player count reaches 0. So if the lobby is destroyed before on game started, then what we really want to do is tell the region server that we're not starting the game. Now that's another interesting thing. So this on game started never gets a reference to the lobby or the proxy or the region server context that was created for this particular game, so it can't inform the region server that it was destroyed. So let's think about that for a moment. When we do game servers.begin game, I'm thinking that, so we have a game instance. Game instance has an ID level name and a server. Thinking that we need a way to have this begin game method return not only the game instance, but also the server that it was started on. So probably the easiest way to do this, I'm not going to introduce another deferred class that has multiple result values, because that would just be a nightmare. We could wrap it up into a struct, or we could just use a tuple. So remember, we're in begin game on region server queue. I think I'm going to change this to returning a tuple of our game instance system and our game instance. Then when we return, now this is going to be interesting the way that we write this. So we're going to return server proxy begin game. That's not going to change, but then we're going to do then. I'm going to say then def goes into tuple.create, passing in our game server, which is server. Whoops, I missed a parenthesis there. Server, and then passing in def.result. So in theory, that should work. I don't know why the type system is being kind of a pain here. Can it resolve method then? It is getting confused between two of our thens. Which ones are these? One that returns... Oh, right. We have to do def goes into deferred.success. Because the then method expects that we return another deferred, so we just return an already defined deferred. So anyway, this way, when we begin a game, we not only get the game instance, but we also get the game instance system that it was started on. What that allows us to do is jumping back into the game lobby. I'm going to change on game started to take in a tuple of game instance system, game instance. So game instance system does that. So then what we're going to do is I'm going to say var game equals, we'll change this to result, and I'll say var game equals result.item2, var server equals result item 1. And then before we contact the database, I'm going to check to see if we were already destroyed. So if status equals lobby status dot destroyed, so if we were destroyed while we were starting the game, remember we can always invoke the destroy method, which the destroy method does check to see if it's active, which I don't think we want. Instead of ensures active, I'm going to say if status equals lobby status dot destroyed, return deferred fail, or throw an exception, doesn't matter. Lobby already destroyed, so we can't destroy it twice. All right. There, that looks better. And now coming back down here to on game started, if status is lobby destroyed, then we'll do server.proxy dot, and I basically want to inform that region server that we want to completely destroy the game. So we'll say something like destroy game, and we'll pass in game.id, and then we will simply return. So if we were destroyed while the game was starting, then we destroyed the game. And that can happen if all the players leave, or if somebody destroys the game manually. So anyway, so we've added a destroy game method to our proxy. So I'm going to go ahead and hit Alt-Enter. inner. So destroy game, and then we'll do game ID. It's not even close. Stop it. Game ID. And so now that we've changed this interface, we can go into... Actually, I'm going to have this return a deferred, even though I don't think we'll use this. For this sort of thing, I like having a deferred so that we can add error handling and all that fun stuff. But anyway, now we can hop into server region, go to systems master, game instance system, and then I can add a public deferred destroy game int game ID. And so server, we have a server.begin game parameters. We should also have a server.destroy game ID, and then we'll just return deferred.success. The only way that this will fail is if an exception gets thrown anywhere in this code path. So in our server, we can now add a destroy game method, which I'm starting to think that the begin game and destroy game and all that stuff should really be moved into another class, like maybe something like a game repository. But right now, so far, that's really just the responsibility of this class, besides its initialization logic for our IOC container. So introducing another class at this point might be a little too much. Actually, we want... No. We want this destroy game... Where am I? Come back here. We want our destroy game method to return a deferred. So we're going to change it that. So destroy game on the game instance system, we will return destroy game, and destroy game will return a deferred. And then for this, we will return fiber in queue deferred. And for this, we've really, at this point, we want to do two things. We want to invoke the game instance that we are creating, or the running game, the service dot, which we're actually never instantiating running game, are we? If I do a search for that, we do it... Yeah, we just create a dictionary that contains this. We don't actually use it anywhere. So I'm going to put a to-do in here. To-do create running game. And then we'll do to-do destroy running game. So this is actually an interesting thing here, where we want what class is going to be responsible for destroying a game. So a game should be able to destroy itself because of anything that happens with the game, like for example someone won, or the timer runs out, or there's a tie, or whatever, or every player abandoned. All of that code is mostly going to be probably going to be inside of the running game itself. And so the running game should be the one that's responsible for telling the game entity service to destroy itself, which means shouldn't it also be responsible for creating itself, passing in the create game there. I think that's actually a better idea. Now that we have a little bit more context of how we're going to actually start using the running game class, I think the running game class is going to be responsible for both creating the game instance object as well as deleting it, or not deleting it, but setting it's destroyed at when the game is finished. So I think that's what I'm going to do. So to create the running game, what we need to do is I'm going to say var game equals container.resolve running game, and I'm going to pass in a typed parameter from our parameters. Then I'm simply going to do return game dot game instance, and then I'm going to take all this code and I'm going to move it into the constructor. So let's get some more space here. I'm going to move it into the constructor of the running game here. I think that makes more sense. So we'll paste that in there. And we will be taking in, for our running game, let's see here. Yeah, okay. So because this is a constructor and because of constructor injection, we no longer need to do container.resolve game entity service. I can say game entity service as a dependency. I can also grab a reference to the game server context to retrieve the config. So let's go ahead and do that. Game server config. Actually, I wonder if I can just inject config directly. Because should the running game... Well, yes, the running game needs to be able to inform the game server context when the game is destroyed. So we do need a reference to the context. So we'll call this application. And of course, because of our typed parameter that we're passing in here, we can now accept a game parameters, even though game parameters isn't coming from AutoFac. It's not going to be instantiated by AutoFac. Instead, it's going to be provided by this typed parameter right here. So with these three things done, we can now say game entity equals service, create game. This is running out of vertical or horizontal space here. Game entity service create game. Now we'll do application.config game server unique ID followed by parameters. And then our game instance, what I'm going to do is say game instance equals new game instance blah, 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 blah with the UDP connection. I'm going to go ahead and alias this out. I'm going to alias this out to config. Oops, that's not how you spell config. Config. And then I'm going to do config UDP connection. And then I'm going to go ahead and hit Alt-Enter to create a game instance property. And I'm going to go ahead and remove the setter so it becomes a read-only field. So thinking about this, so we'll have our game entity. I'm not going to keep a reference to the game entity. I'm going to let that get detached from the ORM. And the reason is because whenever we want to manipulate the game entity or query the game entity, all we're going to need is the ID. And since we are grabbing the ID and storing it in our game instance, we'll be able to do that. So the service methods will take in IDs when we want to manipulate a particular game. So for the running game, let's go ahead and just do an iDisposable. So for dispose, we're simply going to do, we want to go ahead and alias out service into a field, which we'll do like that. And then we'll do service dot destroy game instance dot ID. And then let's go ahead and also create an event, public event action running game on destroyed. And then I will invoke that after we do that. So that, invoke this. And I'm going to actually move this above that so that I want to call that event. I think calling the event before I actually do any destroying of the game makes more sense. So I know I don't have this method implemented yet on service, but that's okay. So now what I can do is jump back into the game server context. Gonna have some fun here. So we'll do game instance. Then I'm going to do game.onDestroyed plus equals onGameDestroyed. I'm not doing a lambda for that. I'm just going to create a method here, and I'll move this down to the bottom because it's private. I'll actually keep dispose on the bottom and do that, and then I'll do fiber in queue deferred. Before I fill this out, I'm going to finish this begin game because after we create the game, we have to add it to our games dictionary. So games, add game instance ID, game. And then for destroy game, we're going to do, I'm actually just going to do games at gameid.dispose. And the reason I'm doing that, we can move this all on one line, actually. The reason I'm doing that is because this accessor will throw an exception if this particular game ID isn't found in this dictionary, which is the exact behavior we want, because that'll be captured by our enqueue deferred wrapper, and it'll tell the master server that we had an error, and that'll all be logged out. So you guys know me. When I don't have to do when I'm just going to throw an error, unless I want to provide a custom error message, if I'm just going to throw an error if an item doesn't exist in a dictionary, I'll just not do error checking because it's going to throw an exception anyway if that item doesn't exist, and that's all I want it to do. I just want to throw an exception and log something out. So then on game destroyed, we'll do, I don't believe games, we'll just do games remove, and then we'll call this game game instance.id. So we'll just do that. And there we go. So when the game is destroyed, it gets removed from our list of running games, and that'll clear out all the memory that might be retained by that individual game. So I think I'm liking this a lot more. So our kind of game server context is sort of the gatekeeper into the running game. And then the running game itself is going to be the gatekeeper into both the game instance as well as the game engine. Now, the game engine is going to be a separate class that runs the simulation, and the game engine won't know anything about databases or anything like that. That's all going to be handled by our running game. So our running game will have methods on it such as add player, remove player, player abandoned, all that stuff. So now we have service.destroyGame. And we can go ahead and hit Alt-Enter, which will jump us all the way back to our BuzzMMO data services game entity service. And this will take in a game ID. And destroy game is simply going to do var game equals database games load or get or find. How do I, it's find. I don't know why it wasn't showing up in my autocomplete. Game ID, and then I'm going to do if game is null, throw new argument exception, game with ID, game ID not found, name of game ID, and then I'll simply do game.destroyDat equals datetime UTC now, and then database save changes. So that should properly, in theory, destroy the game, remove it from the thing. And we could do other things here if we wanted to do stuff like collecting statistics or anything like that. Anything that has to do with the data here, we would do that. But jumping back into our game server context, I think this is pretty much what I want. Of course, I do need to register our running game with our builder, so I'll do builder register type running game as self instance per dependency, and that should be that. If I hit F6, we should get a proper build. We still have that one error. If you notice on the bottom right, that's just caused by our generated component files not having been updated. But hitting F6 should run our code generator, and now we have no errors. So yeah. Can't really test that right now, but what we can do is, well, we can test it, I think. No, I'm not too worried. What we can do is when we go into server region, when we have our systems, when we have our peer, we create the context. If it's a player, we get the game ID, the token, we get the game entity service, get player in game, which returns a user in game entity. And then we log in, and then we return the context. So what we need to do now is we need to create the region server systems. And so let's see. We need to be able to inform the player about details of the game. They need to know all the other players that have logged in, who's currently active, who's not, who's abandoned, and all of that fun stuff. So basically, mostly that information is contained within the user in game, so we need to create a another class that represents a player in the current game that we can send information about back to the player when they join the game. So thinking about this, when we get the player in game, we log in. What I'm going to do here is I'm going to go... Actually, not yet. I'm going to go ahead and create our interfaces first. So in BuzzMMO base components, we have systems.master. Let's go ahead and create systems.game. I've been calling it systems game or systems region. I've been calling it systems region. And we'll create an interface. And we'll create a system. How about game info? So a public iGame info server and public interface iGame info client. So the client's going to be is going to have to be aware of the game parameters. Now the game parameters we already have. The information that we'll have on the client already is the ID of the game, the level that we joined, and we can have information about the players already by extrapolating from the information in our lobby, but I want to actually use a completely different class to represent players in a game, because we'll need to add additional information, such as in addition to their hero and their team, maybe their health, or if they've abandoned or not. We need to make the player aware of all of those players that are in the game, as well as other information. For example, other information like when the timer for the game, or what side has which points and all that stuff, and that's all going to be funneled into this this interface here. So we need a class very similar to our game lobby player details. Let's see here. I'm just going to create a simple class here. Game player details. And it'll be custom serializer. And it's going to have a lot of the same information as our lobby player details, but it is a fundamentally different concept. So I'll have public int ID. We need the player ID, of course. Public string name. Did I set those as private sets earlier? No, I didn't. Public hero, game hero. Public game team. Public bool is connected. We need to know if they are currently connected. We also need has abandoned. So we need name, hero, is connected, has abandoned. And later we can add things like score and level and other information. But this is enough for now. So let's go ahead and just write our saves. I need to come up with a better... what do you byte? No. What do I serialize team and hero? I think I serialize them as a byte, don't I? Save... yeah, I serialize as a byte. Byte... hero. I need to come up with a better solution for the state management. I will soon. Writer write is connected. Writer write has abandoned. And then we do the opposite. ID equals reader read int 32. Name equals reader read string. Hero equals game hero reader read byte. Team equals game team reader read byte. Is connected equals reader read boolean. I know I complained about this before, but I really wish boolean that you could do method overloads based off of return type. Because funny enough, I swear I've already mentioned this before, probably 100 times. But funny enough, the actual CLR, if you were to go in and write your own IL bytecode, does actually allow you to create method overloads based off the return type. So you can make a method named something, like let's just say read, and then it would figure out, based off of what I'm assigning it to, it would infer which overload of read to use. Does it use the string one or the int one, and so on, so on. That would be really cool, but it's not happening right now. Anyway, so that's our game player details. So now coming back into our game info system, we'll want to have a void add player, game player details player, and let's see. Now this is kind of interesting. Should we be able to remove a player from a game? So we're already building in the concept of players abandoning. But should we ever notify, beyond saying, hey, this player has abandoned, should we ever do any additional notification? And if a player joins, should they get the historical information about the players in the client or in the game already? I think I'm actually just going to treat a player abandoning or having his abandoned flag set to true to indicate that that player is no longer in the game. And I'm not going to add a separate remove player method. So I'll have an add player and an update player. Game player details player. And so we have our iGameInfo client and our iGameInfo server. So now we have a system that we can use to send metadata about the game to the client. So let's go ahead and implement the server side to that. In our BuzzMMO server region, let's go ahead and create a new namespace called systems.client, or just systems. Let's just call it systems like we did before. And I'm going to create a new class called GameInfoSystem. And for this, in our game instance systems, we do master system base. Do we have a... so we have master system base, which is just this. We do it so we don't have to redefine the context here. But in our server, we have player system base, which inherits from client system base. And client system base is actually literally the same thing as our master system base. Let's see if there's really any difference between these two, because I should have really had master system base inherit from client system base, because actually it does the exact same thing. All right. So that means that our master system base right here in BuzzMMO server region, I can actually replace literally all of this code by simply having it inherit. Well, no, wait a sec. We couldn't do that because we have the iMaster system base. But in our server, we have the iInternal system, which is literally the same thing. The difference is only the name of the method. And this is internal. Right, this is internal, but it uses this client systems class, which I believe we kind of fudged in here by creating our own iSystem factory. Yeah. Okay, so we couldn't do it before, but we can do it with the player system base. So in our BuzzMMO server region, go ahead and create a class called player system base of 2, which takes in a T server interface, T client interface, and it's simply going to inherit from... What is it going to inherit from? Client system base, passing in our context type of player context game, passing in T server interface and T client interface. And that's literally all we need to do to create our systems. Simply inherit from this. And this is just a convenience. This just pre-fills in the player context game generic parameter. So now what we can do is jump into our systems game info system. I don't believe I have to annotate that with anything. No, I don't. So game info system, and I can say simply inherit from player system base iGameInfo server, iGameInfo client, and have it implement iGameInfo server. And we'll leave it like that as it is, because now we can jump into our peer. And jump into our create context. So now what we want to do is we want to initialize that system, that game info system on that client, on this client connection. And we need to hook it into a running game. So remember how our context, our master server context, our game server context, it's kind of the gatekeeper for our running game. So what I'm going to do here is in our peer, what we need to do after we log in, we want to do application dot add player to game, passing in the context as well as the game ID. How about the game ID first and then the context? So add player to game will look up that game ID, and then it will add the game info system to it. Or it'll tell the running game, hey, this player just connected. So on this, I can go ahead and Alt-Enter, add player to game, and I'll move this up. This does not need to be deferred at all. So what I can do here is simply say fiber.enqueue. Or actually, you know what? I am going to have this be deferred. Say return fiber.enqueue deferred. And before I implement this, I'm going to jump back into our peer, and I'm going to say application add player to game, but then I'm going to say on fail disconnect. Which actually I could just pass straight in. So on fail disconnect. So if we failed at any point to add them to the game, go ahead and disconnect. So now I can jump back into game server context, and inside this enqueue deferred, I can say var game equals games game ID, which it will fail if no such game exists. And then I can do game add player context. And now we can jump into the game here. And so this is an interesting thing. How do we want to handle synchronization in our running games themselves? We could go ahead and create another fiber here. Or, see, we're going to already have a game engine class that's going to actually perform the simulation, the AI, the pathfinding, and all that stuff. And it's going to run a basic tick, you know, like 30 times a second, 60 times a second, whatever. I would actually want adding the player or removing a player to hook into that, so we only have to wait for... so then we can do everything in one shot when we add the player. And go away, CC Cleaner. I don't want you. So for now, I'm not going to do any synchronization. Instead, I'm going to say if context systems contains game info system, throw new RPC exception, player is already in a game. To do validate that player is actually in a game, and we'll do that later, because I think what I'm going to do is when we create the game, I'm going to create a placeholder for every single player that's supposed to be in the game. So there'll be another class that represents the player actually in the game. And that placeholder will stick around even after the player disconnects. So that way, when they reconnect, they'll have access to all their information, such as which game object is their avatar and all that stuff. But we'll do that later. For now, what I'm going to do is I'm simply going to say var system equals context systems create game info system. And then I'm just going to do for each var, or how about just system proxy add player new game player details, and just pass in some bogus information. And otherwise, I don't really care. Now, the last thing I'm going to do here before we test this out is I'm going to jump into game player details, and I'm going to add a toString here. Actually, I'll format it myself. This will be, what was the format that I used for our game lobby details? So just, okay. So game player ID name hero team is connected, not connected. Oh, what did I do wrong? What? Missing closing delineator. Oh, I guess, am I? I don't think I'm missing a... Do I have too many? Or am I just having a case of the dumb here? maybe it likes parentheses? Huh. Okay, I guess format strings like parentheses. And then we will do has abandoned. There we go. So those are all of our details about that. And actually, we can turn this into an expression body, too, to clean it up a bit. In fact, I'm going to do that here as well. Come on. Turn you into an expression body as well. That looks a lot cleaner. Okay. So now we hit F6. And so far what we've done in this video is... I'll make sure we start Photon. Master server, start as application, game instance 1, start service, and then go ahead and open up my logs. So what we've done in this video is we fixed a issue with our... Actually, let's just see if this works first. I'm going to have my logs open on the other screen, and I'll tell you guys if anything interesting happens. Now let's go ahead and start the game. Recompile our Unity package, stuff and things. Hit start. Admin, create, start. Joining game, player connected. Oh, we will get an error. Disconnect by server logic. So we did get an exception. Invalid exception. Component of type iGame server was not registered. Did you forget component interface? I'm glad I made that that thing. We actually have two problems right now. So I'll open up the C# client project in the meantime, and let's fix the first problem. First problem is my BuzzMMO base components in my system's region game info. I forgot to annotate this with component interface. Now the second issue, so let's go ahead and recompile that. The second issue is that I never created the client-side copy of the system. So let's go ahead and do that right now. Visual Studio is sitting on my another monitor right now, hanging, as Visual Studio likes to do. Servers have restarted, which is nice. Let's jump into code game server. Let's create our systems. Let's create a class called game info. Game info does need an annotation, I believe. Does not need an annotation, never mind. Unity system base for iGame info server, iGame info client, and it inherits from iGame info client. Go ahead and do our add player and update player. For add player, I'll just go ahead and debug log player, and I'll do the same thing for update player. Okay. So this will tell us if our add player method is being invoked, which will indicate that everything is working smoothly. So let's go ahead and hit play, or eventually hit play when Unity decides to get around to it. Now, in theory, this should work. I haven't actually tried creating a system from the region server yet, so this will be interesting to see. And got another disconnect. iGame info server was not registered. And this is happening on the app log. This is not happening on the main log. So we have an issue here. So let's jump over into BuzzMMO again. And I think the issue is that I'm not registering our... So our system type registry scanned master server context assembly, and then we auto map the assembly. In our game server context, we do none of those things. We scan the assembly, but we never create our component map. In fact, do we even send our component map to our peer? Oh, we should, actually, since we instantiate a player game context, which inherits from client context. The first thing it does is sends the systems component map, which is set to application.player systems component map. So what I can do here is I need to scan for those interfaces. So I do it in configure, and I'll simply do what we did here, which is going to be player systems component map auto map assembly, and it'll simply be type of iGame info server.assembly, and the interface is of course going to be component interface attribute. So if you guys can see that right there. Now let's hit F6 for one last time. Come back over here. Servers have been restarted. Jump in here, hit start. Check this out. Game player 1 bled, none, not connected, active. So we see that in the game context, we should have our systems. And that's interesting. So we have our game info system, but our game lobby system was never destroyed. That's an interesting thing that we'll deal with later. But anyway, we have our level 1 has been launched. Our game UI is being overlaid properly. And we have our game context. All right, so just to recap the video. I don't know why I clicked on that. Just to recap the video, what we've done is we fixed a... I know it's not super important that we fixed this potential... or it might not seem super important that we fix this potential... Come on, where did I edit this code? I thought that it would show me where I edited the code on the left-hand side, but I guess it doesn't. Fix a potential race condition with having the game lobby destroyed before the game has started, which can potentially happen depending on how long the region server takes to spool up. And what that allowed us to kind of explore is the ability for us to destroy the game from the master server to the region server, which also resulted in us having to consider here how we actually destroy a game from our server, which brought us into creating our building up our RunningGame class, which is responsible for keeping track of players and owning the game engine and all that fun stuff. So that really helped with a lot of things. And then we added the ability to add player to the game, which of course is invoked when the player connects directly to the game server. So we go through this nice little hierarchy. And then now we have this add player method, which creates our game info system, which is responsible for sending metadata to the game client. Now, things like the position of actors and stuff like that are probably not going to be handled through our systems. They're probably going to be handled through some sort of synchronization loop where we send, X bytes of data per X time to keep everyone updated as to who is where and so on, which will be handled through a different transport mechanism, which we'll be looking into. Another thing that we're going to be looking into is synchronization. Right now, our add player is not synchronized if two players connect at the exact same time, although it actually technically kind of is synchronized off of the master fiber here. It's not synchronized at the game level, and we want to make sure that that's always true because we are using not thread-safe code here. But like I said earlier, we are going to be doing synchronization on the game engine tick itself, which will allow the game engine to manipulate all of its internal state to actually put the player into the game, and so on. And then in addition, we're also going to expand the running game to keep a list of all the players that should be in the game, so that when we disconnect and reconnect, we can get back and get our character back and all that fun stuff. So with that, I think this is about it. And we'll see you guys in the next video.